a thin and bendable black sheet. This is a next-generation solar battery, developed in Japan, called Perovskite Solar Cell.
In the future, electricity won't be purchased but generated where it's used. Local production and local consumption will become the standard.
Perovskite solar cells can be installed even in places unsuitable for conventional solar panels. A technology that revolutionizes the traditional concept of power generation. It's being developed at a rapid pace across the country now.
What's being transmitted through various distribution networks can be generated closest to where it's needed.
With the technology garnering strong interest worldwide, the market is seen to exceed $16 billion by 2040 by one estimate. And
unless we commit to doing all we can do, achieving carbon neutrality will be quite difficult.
with the Japanese government setting a target of raising the proportion of renewable sources to about 40 to 50% of total energy production. Perovskite solar cells are seen as essential. This is a soccer facility in Narahamachi, Fukushima Prefecture, called J Village. Atop the grass covering, the rotary are numerous black sheets.
These are Perovskite Solar Cells.
Fukushima Prefecture launched practical trials for Perovskite solar cells in 3 locations from March 27th. They're installed on slopes and the walls of buildings to evaluate how power generation efficiency will change over a 4-year period. At J Village, 60 Perovskite solar cell panels have been affixed to sheets that prevent weed growth.
The electricity that's generated here powers the lawn mowing robots. It's first collected in a storage battery, then supplied to the lawn mowing robots, which cut the grass and weeds. Since it's where the cleaning robots move around, the wiring is buried in the ground. The electricity is transmitted to this outlet, and from here, it's supplied to the chargers of the cleaning robots. See? You can see it moving over there.
Depending on the results of the trials, they're considering installing them on embankments along highways and rivers.
Beyond the current sites, there are many riverbanks and slopes along highways and railways that can potentially be used to install solar cells.
Perovskite solar cells are next-generation batteries made by coating iodine, lead, and other solutions on films and glass. Thin, lightweight, and bendable, they're now being installed in various locations for practical trials. On the roof of a bus rotary at a commercial facility opened near Osaka Station in March. And even at the venue of the Osaka-Kansai Expo. These trials are being carried out by Sekisui Chemical.
Right now, we're heating the furnace to make the crystals. It's sent in like this from here. This is the furnace, so it's hot. And it comes out like this. this black substance comes out and is wound up there.
Sekisui Chemical's Perovskite solar cells are made by thinly coating the substance on a film made with the same material used for plastic bottles. The sheets are 100 micrometers thick, with the perovskite layer just 1 micrometer. The weight is about 1 kilogram per 1 square meter, a tenth of that of conventional solar cells.
The main characteristic of our product is that it's in a film form and lightweight. We're planning to actively install it in places without silicon solar cells, or where they can't be installed. First, we're looking at disaster use sites, such as the roofs of gymnasiums. They're places where conventional silicon solar cells can't be installed. So if we can do that, electricity can be supplied without interruption during disasters.
To mass-produce perovskite solar cells, Sekisui Chemical partnered with the Development Bank of Japan to establish a new company called Sekisui Solar Film. They aim to manufacture perovskite solar cells with a capacity of 100,000 kilowatts, equivalent to the energy consumption of about 25,000 households by 2027 and 1 million kilowatts by 2030.
Electricity won't be something that's purchased, but rather generated where it's used. Local production and local consumption will become the standard. The question is, where is electricity needed? There are many places now where silicon solar cells can't be installed. So, we hope that electricity can be generated anywhere it's needed. You're confident technology from Japan can win against overseas competition? I think so. We want to build a model case of winning with technology and of continuing to win with a sustainable business.
Why is the technology of perovskite solar cells grabbing the spotlight now? The Japanese government is aiming to increase solar energy output 2 to 3-fold from fiscal 2023 levels by 2040. As the installation of conventional solar panels is limited to areas such as mountains, meeting the government's goal requires the adoption of perovskite solar cells which are thinner, lighter, and can be more easily deployed anywhere. Also crucial is increasing solar power generation in cities, a challenge being taken on by Panasonic Holdings. The company is currently developing glass materials equipped with perovskite solar cells for use in buildings.
We're working on glass which is coated on the inside with these perovskite solar cells. It's a construction material, and we're looking at putting it into the windows and walls of buildings. For windows, it's necessary to control the transparency. So we consider that a very important point and feature of our technology.
Panasonic grinds a section of the power generation layer using lasers and is developing perovskite solar cells with varied transparency.
For example, if the bottom section is transparent, people feel a sense of fear, and we have customers who want it to be blacked out. In those cases, we gradually increase the transparency so that visibility is high at eye level, and darker the higher you go. Many buildings now have big glass panes. Sections above eye level, very close to the walls between floors, can be made completely black. We believe that this is something we'll be able to do.
As perovskite solar cells can generate electricity even in cloudy conditions or with low light, they can be installed in any direction. They say that makes them suitable as window glass for buildings. Panasonic expects to start test sales from 2026.
Glass-structured buildings have really been growing in number. If these buildings can change to have solar cell-equipped glass, it'll be possible to have a world where rather than electricity being transmitted through various distribution networks, it can be generated closest to where the demand is.
At the same time, one company is developing consumer use products. A startup launched at Kyoto University called Enicote Technologies.
We're putting a lot of effort on the usage case of generating electricity indoors. This can be used in place of dry cell batteries, so as long as there's light, it can really power various things.
Enicote Technologies is developing products using small perovskite solar cells, such as room thermometers, electronic memo pads, and product tags. They say a higher level of technological expertise is required compared to large perovskite cells.
Large electrical currents can flow even if there are additional obstacles. You could say it's like a big river flowing over small rocks. But with electrical currents indoors, this light here only has an energy of about 100th or 1,000th of sunlight. So, the electrical current is smaller, like a gentle flowing small river. That means if there are even some small rocks, for example, it'll be interrupted, unless the film is extremely clean. Otherwise, electricity can't be generated indoors. In other words, we're exceptionally skilled in technology to make these clean films.
Perovskite solar cells are just within reach of practical applications. However, for them to become widespread, there are still obstacles that need to be overcome. Professor Hiroshi Segawa of the University of Tokyo has long researched perovskite solar cells. He points out that durability and electricity conversion efficiency are pressing issues.
Durability is still only about 10 years, and conversion efficiency is also still only 15% or so. At the research level at labs, including ours, small cells have a conversion efficiency of 25%. Development of the second generation of perovskite solar cells is a pressing issue now. We need to develop conversion efficiency modules of 20% or higher and ensure that durability is 20 years or more.
Professor Segawa says if advancements are made in development and mass production is achieved, manufacturing costs will continue to fall. He also points out that the widespread use of perovskite solar cells is essential from another perspective.
The most important point is from the standpoint of economic and energy security, which is a key issue now. For example, if Japan can produce the raw materials for perovskite solar cells and also make the modules, and if everything from end to end can be manufactured domestically, that would lead to energy self-sufficiency in a true sense and contribute to economic and energy security.
With rivals overseas in China, South Korea, Europe, and other countries working on perovskite solar cells, a major challenge for Japan will be building a business model that can continue winning in the global market.